Okay, I thought that before we begin, I want to, cause today we're going to be looking at activity. We're going to start now. We're going to start by looking at activity 6 in page 127. Okay, so, but before that, okay, because the activity is determining VF and lambda, which is determining the frequency, the wavelength, and the wave speed. Although we have actually covered this previously before, we're going to look a little bit more deeper into this today. But I thought that I wanted to begin by showing you the interactive that I showed you last week. Okay, and if you take a look at this, so this is, of course, if I press play, it's going to start to oscillate lah. Okay, at a certain amplitude and a certain frequency. Okay, but what happens if let's say I increase the frequency? Okay, just now was 1.5, right? Take a look at what happens to the wavelength. Okay, remember that wavelength is the distance between one crest and the other crest, or one trough and the other trough. I know that it is, it's becoming smaller and smaller, but let's not talk about this. Let's just talk about the distance between one crest to one crest, or one trough to one trough. That is the wavelength. Okay, so if we find that, look at what happens lah. Okay, when the frequency increases, okay, this is what happens. Okay, increase the frequency to maximum and you see this lah. Okay, you will find that actually, you can notice that there is a change in the wavelength when you change the frequency. When I reduce the frequency, let's say I reduce it to a very it's very difficult to see. Hold on. Okay, like this lah. Okay, you notice that we have to look for points in the same phase lah. So here and here is the only one that is in the same phase. Okay, because there's not enough crests. You can't see two crests. There's only one crest. You can't see the other crest. There's only one trough. You can't see another trough. So you find that when you reduce the frequency, the wavelength also changes. Okay, so let me show this again now. So small frequency, okay, as I get bigger, okay, this is medium frequency. Oh dear, hold on. Okay, let me restart. Okay, medium frequency, and when I increase it all the way to maximum, okay, you will see that the frequency is like this. Okay, so that's the first thing. Okay, second thing, let me set this again. You know what? I'm going to change to loose end or no end. Okay, the endless one. Okay, so again, the same thing. Okay, small frequency, big frequency. Okay, you see the bigger difference over here. Okay, and even smaller frequency. Oh, it's a bit too much, sorry. Okay, even smaller frequency. Notice that the wavelength changes. Okay, now let me set it at a normal frequency. Let's say I set the frequency to 1.81. Okay, now I change the amplitude. Okay, so the amplitude now is at 0.75 centimeters. Okay, you can see that there is 0.75 centimeters. Now if I increase the amplitude, look at what's going to happen to the graph. Okay, when I increase the amplitude, look at what happens. Okay. Manakala, if I decrease the amplitude, look at what happens. Okay, so the question now is, which one affects the wavelength? Okay, so take a look at this one. Big amplitude, okay, small amplitude. Oh, sorry, that's small. Okay, this is small amplitude. Okay, let me maintain this one. Now let me change the frequency. Big frequency, okay, small frequency. Okay, so my question to you, okay, which I want you to answer in the poll now is, what affects the wavelength? Does the amplitude or the frequency affect the wavelength? Okay, so 2 people said that the amplitude affects the wavelength, okay, and another 15 people said that it is the frequency. It is the frequency that affects the wavelength. And the thing is, okay, if you take a look at, if you remember in our wave formula, okay, if you remember the wave equation, which we saw last week, we saw that V equals to F lambda. Okay, this was the formula for wave speed. Okay, now if you take a look at this, okay, there are only three things in play here, which is the wave speed, the frequency, and the wavelength. So the correct answer would be the frequency. Because if let's say I bring the frequency over the other side, we find that the wavelength is affected by two things, the wave speed and the wave frequency. So the amplitude is not correct. Okay, so to the two people that voted the amplitude, okay, learn from this mistake, okay, and make better choices. All right, so let's talk about this, the relationship between the frequency and wavelength. Remember, the wavelength is the distance between two crests or two troughs or 2 points that are on the same phase. If it's going down, so all these are wavelengths. So when we compare the frequency between diagram A and diagram B, this is diagram B. So diagram A, this is diagram B. We find that the frequency of A is bigger than the frequency of B. If you remember the video, the simulation that I showed you just now, right? The bigger the frequency, the more waves are able to produce, but it is shorter, okay? But when we compare the wavelength, okay, the distance between two crests, okay, here is one crest, here is another crest, we find that this distance is very small. Right? This distance is very small, this distance is very big. Okay, this is only like 1.5 centimeters. This is 4 cm. Okay, so we find that A is smaller than B. Okay, the wavelength of A is smaller than B. So look at this. Frequency of A is bigger, frequency of B is smaller. Wavelength of B is smaller, wavelength of B is bigger. So the relationship between the frequency and the wavelength should be written as the bigger the frequency, the smaller the wavelength. Okay, the bigger the frequency, like in this case, the smaller the wavelength. Okay, or in other words, it will be inversely proportional. Okay, but I still kind of prefer you to write this. Okay, the relationship between frequency and wavelength, besides being inversely proportional, it should be the bigger the frequency, the smaller the wavelength. And so when you draw a graph of f against lambda and f against 1 over lambda, you will get these two shapes. Since f and lambda, since the frequency and the wavelength are inversely proportional, so you will get a graph that looks like this. Okay, it's a curved graph. Okay, and if you convert the wavelength into 1 over wavelength, you get a directly proportional graph. Okay, so under your graphs over there, please write the relationship between the two graphs. Okay, f is inversely, okay, proportional to lambda. But over here, it will be f is directly proportional to 1 over lambda. So just be careful. We look at the graph and we look at the shape of the graph. The shape of the graph will tell us the relationship. If it is curved like this, inversely proportional. If it is a straight line starting from 0, it is directly proportional. Okay, so make sure you write this down, these two sentences, okay, down under each graph, okay, so that you remember how to write the relationship for each graph. All right, let's look at the relationship between speed, wavelength, and frequency. Okay, which is what we call, the wave equation, V equals to F lambda. This is the relationship that we're going to talk about. Okay, but let's take a look at this now. So, determine the distance between the two successive crests. Okay, so name the distance between the two successive crests. The distance between the two successive crests is always called a wavelength. Okay, the time, which is determined by the displacement time graph, okay, the time between two crests or two troughs is known as the period. Okay, so we've seen this in last week's class. So today is kind of just like, just remember again. So given the equation, speed equals the distance over time, and period is 1 over frequency. Okay, so we derive the equation for the speed of waves. Okay, we saw this last week also, so I'm just going to go into this. It will be V equals to F lambda. Okay, and again, this equation is also known as the wave equation. Okay, V equals to F lambda is also known as the wave equation or the wave speed equation. Okay, the same thing. But basically, it's to count the wave speed. Okay, and the wave speed is related to the frequency and the wavelength. Again, not the amplitude. Okay, the amplitude is not involved. Amplitude is just how high or how low the graph is, but you can have a high frequency, high amplitude graph. Okay, high frequency, high amplitude graph will be, uh, sorry, high frequency, high amplitude graph will be like this lah. Okay, very very high frequency. Okay, because many waves, and very high amplitude because very tinggi dan very rendah. Okay, but the wavelength is not affected by the amplitude. No matter how high your graph is or how low your graph is, the wavelength is not how high or how low. The the wavelength is always how long, okay, between the two highs or the two lows. Okay, so that one is affected by the frequency. Now in the lab, okay, we have this apparatus which we call a ripple tank. Okay, and after this, we're going to watch a short video. Okay, so this ripple tank over here, there's water over here. Okay, there's a small tank over here, and there's a little bit of water lah. Okay, shallow water. And what's going to happen is you're going to have a vibrator. So this is a vibrator, penggetar. Okay, so this is a vibrator which is a piece of metal. Okay, that is connected to a motor. And so when the piece of metal connected to a motor and you touch the water, it's going to touch the water a lot of times. And what you're going to see is you're going to see wave patterns. Okay, and then we use an equipment which is called a stroboscope. Okay, to mark the two successive dark lines on the white paper, and then we measure the wavelength. Okay, with a ruler. Okay, so of course, talking about this is really useless lah. So let's watch a video first. Okay, so you see the wave patterns being formed. Okay, the white color lines over here, okay, are the crests. Okay, and then the black parts over here are the non-crest lah. Okay, which also includes the troughs. But you will see that the white color part okay, is very thin, and the black color part is very white because when the light shines, okay, it's only able to shine in this part, okay, in order to be seen as a white line. The rest of it, all this, okay, becomes a very blurred darkness. That's why you see that the darkness is much thicker than the brightness. Sorry, the dark lines are much thicker than the bright lines. Okay, because the bright lines represent the crest, which is very easily seen. Okay, if you take a look, if you remember, okay, so the light, okay, so where is the light shining? The light is not being shown here, but the light is somewhere up here. Okay, maybe there's a lamp over here, okay, that is shining on these waves. So this is the vibrator that is connected to a motor. Okay, so this vibrator is going to touch the water. So this is a ripple tank that has water. So when it touches the water, it vibrates, so it goes up and down, 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 but at a very fast pace. Okay, and what you're going to see is you're going to see the waves being produced. So the wave produced, the light shines on top and produces this shadow at the bottom here. Okay, so we can use a phone camera or as I said just now, a stroboscope. Okay, a stroboscope is like a wheel that has holes. Okay, so at this point it's a little bit difficult to explain that, but it helps us to see. Okay, actually your phone camera also can see one. It helps us to see the crests, okay, which are represented by the white lines, and from there we can determine the wavelength. The wavelength is the distance between one crest and another crest. So this is the wavelength. okay, of the wave, okay, which you determine by looking at the two crests lah. Okay, so again, now remember that this wave pattern, okay, is produced by a plane or a straight, okay, a straight vibrator. Okay, so you produce plane waves. A circular wave is if your vibrator is connected to a small ball instead of a piece of metal or piece of wood that is, that is vibrating. Okay, so it depends on what kind of wave you want to produce lah. But whether you produce a plane wave or a circular wave, you will always see the crests, okay, very easily form. And again, the distance between the two crests form the wavelength. The distance between the two crests form the wavelength. Okay, which is affected by only the frequency. Okay, yeah, okay, fine, and the wave speed, but the frequency, okay, is the one that changes, whether these white color lines become nearer or further apart. Okay, is determined by the frequency of the vibrator. Okay, so since the wave is moving this way, okay, for a plane wave, this is what we call the direction of propagation. Remember the word propagate, I mentioned this last week, we don't say movement of the waves. That is the wrong word to say. Okay, we say waves propagate. Okay, because we determined this okay, at the very beginning I said that actually it's not the waves that are moving, the waves are just propagating, and what they are actually transferring is just transferring energy. They are not moving themselves. That's why we have to use the word propagate. Because if you say the word the wave moves, you're totally not getting the right concept. Okay, because waves don't move. Okay, they just propagate. Alright, so the circular wave, since it starts from a central point, okay, it's going to propagate in all directions. Okay, it's going to move in all directions. Okay, starting from the center of the circular wave. Okay, so this is how the wave would be like. Okay, if it was plane wave, and this would be how the circular wave looks like. Okay, if it is if it is starting from the center. Okay, so lukis corak gelombang bagi frekuensi motor rendah dan motor tinggi. Okay, so low frequency and high frequency. Okay, for low frequency, remember guys, we're not talking about this anymore. We're talking about what we expect to see on the white color paper. Okay, for low frequency, you will find that the distance are further apart. Okay, whereas for high frequency, the distance is much more nearer. Okay, there's a difference between the white and the blue lines. Okay, we're going to say that the blue lines, these represent the crests. Okay, manakala these red color lines represent the troughs. Okay, the blue lines represent the crests, the red lines represent the troughs. And that's why in a low frequency, you find that the wavelength is very far apart. They're very big. Okay, in a high frequency, okay, more waves are produced in high frequency, so the waves are smaller. Sorry, not waves are smaller. Waves are nearer to one another. Okay, so low frequency. Okay, and this is what we call the direction of propagation. Okay, of waves. Okay, so the direction of propagation is just denoted by this black line over here. Okay. All right. Let's take a look at exercise 2. We're almost done with this subtopic. I kind of want to finish this by Wednesday. All right. So calculate the frequency of water waves with a wavelength of 4 centimeters traveling at the speed of 1.6 cm per second. Okay, so you notice that the wavelength is given. So this is lambda. And the speed is given. This is v. So can we calculate the frequency? Can lah. Okay, we don't even have to change the unit because both are already in cm. Okay, so it'll be just 1.6 divided by 4 because it's v equals to f lambda. V is 1.6, lambda is 4. Okay, f. You bring that 4 down here, you get 1.6 divided by 4 equals to 0.4 hertz. Okay, reminding you again that the unit for frequency is hertz, Hz. Okay, the full name for hertz is HERTZ lah. Okay, all right. Before a concert starts, a musician tunes his guitar string to a note A, okay, which is the frequency of 440 hertz. Now, what is the wavelength of the sound wave produced by the guitar if the speed of the sound in the music hall is 340 meters per second? Okay, notice that our speed now is in meter. So you know that the wavelength is also going to be in meter. Okay, frequency is given as F, and since it is hertz, we don't even have to worry about changing anything. So this is V, this is F, we can calculate lambda. Okay. All right. Sorry, I'm going to just go through everything first, and then I'm going to give you some time, and then I want you to calculate this and give me the answers lah. Okay, diagram A shows the displacement time. This one is actually the same, almost the same as the homework that you did last week. Okay, so you should be able to answer this. Oh no, hold on. Okay, question number 4 also the same. Determine the amplitude, wavelength, and wave velocity. Now, this one is a little bit tricky. Diagram 10 shows a wave. The speed of the wave is 4. Okay, the distance of the 5 consecutive crests. So 1, 2, 3, 4, 5. Okay, it's 8 meters. Okay, calculate the frequency of the wave. Now, in order to calculate the frequency, I have the speed, but I don't have the wavelength. What is the wavelength? It is definitely not 8. Okay, don't be so easily fooled. Come on. 5 crests, 8 meters. So what is the wavelength? Find the wavelength, then you can find the frequency. Okay, and then of course, this is the last question. Which one has a higher frequency? I want you to answer this now. Okay, so I'm going to give you 10 minutes. Okay, I'm going to give you 10 minutes to answer all questions. Okay, number 2, 3, 4, 5, and 6. Okay, 10 minutes should be more than enough. Okay, and then I'm going to call people to answer these questions. Okay, so take some time, answer it now, and then I will come back in 10 minutes. All right, let's begin. Can? Okay, number 2. Can I have Elvin, please? What is the answer for number 2?
0.77.
Unit?
Meter.
Okay, 0.77 meters. According to this is 0.773 lah. But okay lah, 0.77 also is not a problem. Okay, good, thanks. Amplitude. Can I have Vivian, please? What is the amplitude for this displacement time graph?
10.
Okay, 10 what?
cm.
Okay, very good, 10 cm. This is a mistake, it should be 10 cm. All right, period, Bernardine?
0.4 seconds.
Okay, good, 0.4 seconds because it's determined by the one wave until the next wave. All right, good. Frequency. Sorry, frequency is Steffi?
2.5 hertz.
How do you get 2.5 hertz?
1 over 0.4.
Okay, very good. Okay, 1 over 0.4, so it will be equals to 2.5 hertz. All right, next question. 4A, the amplitude for this, please, Chloe?
15 cm.
All right, good, 15 cm. cm, yeah, okay, sorry. So 15 cm is the amplitude. Okay, the wavelength. I-rail, this one, 20 what? 20 ringgit, 20 pieces of paper. You don't remember the name. How do you count the wavelength? The wavelength is from one side to another side, right? 20, chang, chang, chang. You don't even have to remember. You just have to open your eyes. I-rail is 20 cm. Okay, wave velocity. Please open your eyes. Diane, wave velocity, please. 0.075. No lah, hello. Wrong question. 0.075 is this one already. How do you get the wave velocity 0.075? How do you get 0.075 though? Formula is V equals to F lambda. You already have lambda over here. Okay, all you have to do is to find the frequency, which is 5. 5. So it's a very simple multiplication. V equals to F lambda. 5 times 20, you get 100. Okay, and because you're using cm, okay, so you will have to write it in cm per second. Okay, not being confident should not be an excuse to try. Okay, that's how we build confidence, by trying, by making mistakes, and by moving on from those mistakes. Being stuck in a mistake is something that you should not be doing. Okay, it's all right. Can I have Elvin again, please, for number 5?
2.5
2.5 what?
Hz.
How do you get 2.5 though? Frequency of the wave. So you need to have the wave speed is 4. V equals to F lambda. Wave speed is 4. What is your lambda? Oh, sorry. Frequency is F. F you say is 2.5. What is your lambda, Elvin?
1.6.
How do you get 1.6?
8/5.
8/5. Are you sure it's 8/5? How many wavelengths are there? There are 5 crests. That's correct. How many wavelengths are there? Take a look. 1 wavelength, 2 wavelengths. Do you see what I'm getting at? 3 wavelengths, 4 wavelengths. So you shouldn't be dividing by 5. You should be dividing by 2, because there are only 4 wavelengths. Wavelength is the distance between 2 crests or 2 troughs. Okay, distance between 2 means 1 distance. Okay, so the wavelength actually is 8 divided by 4, because 8 meters, 4 wavelength. So 1 wavelength is 2. Okay, therefore you will get F equals to 2 Hertz. Okay, it's a good try. Okay, it's a good try, but this is, again, this is a very common mistake. Okay, so we learn from this mistake. Okay, remember, wavelength is the distance between 2 crests. So you need to make sure, okay, 2 crests is 1 wavelength. 2 crests is 1 wavelength. You want to count how many wavelengths are there, not how many crests. Okay? All right, number 6. Can I have... okay, Vivian, can I have the answer for this, please? Number 6. Which has a higher frequency, A or B?
Is it B?
All right, graph B. Graph B will have a higher frequency. Okay, guys, let's keep answering all the way to the tutorial, so that on Wednesday we don't have to answer too many tutorials. Okay, I'm going to go straight into this. We'll answer this as we go along. Okay, simple pendulum. Okay, it's oscillating between 3 positions, A, B, and C. 1 complete oscillation, okay, is counted from, let's start with Wong.
D.
Okay, the answer will be D. A to C and C to A must come back. Okay, it cannot be A to C. Or A to C is just half an oscillation. Okay, question number 2. The diagram shows the displacement distance graph for a wave at a given instant. Okay, so the amplitude of the water waves, blah, 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 which symbols represent the amplitude and the wavelength. This is 2 different answers. Amplitude is what? And wavelength is what? Can I have Chen He for this, please?
Amplitude is A and wavelength is B.
Wavelength is B, amplitude is A. Okay, so this is a this is a very, hold on. Okay, the problem is this. This is a displacement time graph. It is not a displacement distance graph. And since this is a displacement time graph, B is not the wavelength. Okay, it cannot be the wavelength. Okay, so this is a little bit tricky. Okay, there is only one symbol that represents both the amplitude and the wavelength. Okay, and so in this case, the amplitude is actually D. This is the amplitude. But the wavelength is actually A. Okay, this whole thing is the wavelength. If this is a displacement time graph. Okay, we have to look at it from a different point of view. But, okay, as I said just now, if it is from crest to crest, we have to make sure that this is a distance graph, not a displacement time graph. Okay, so the wavelength is actually given by here, from one crest to another crest. Okay, it's like this, going back and forth. Okay, a little bit tricky, this one, so please mark a star with this. But it's a good try. Okay, it's a good try, Chenny. All right, number 3. Can I have Rahman for this, please? Which is true?
B.
Okay, the answer will be B. Very important. Only the energy is transferred, okay, from S to U. This one, D, would have been correct. The particle U oscillates in a direction that is parallel. The word parallel is not correct, okay, because this is a perpendicular, because the waves are going up and down, but the propagation is going this way. So it's not parallel, it's perpendicular. Okay, and this is known as a transverse wave. Okay, when the oscillation and the propagation is perpendicular to one another, so it's a transverse wave. All right, number 4. Can I have Carlson for this, please?
B.
Okay, the answer will be B, perpendicular, as we mentioned just now. All right, good. Number 5. Can I have Leong for this, please? Which 2 points are one wavelength apart?
D.
Okay, good. D. Thank you, Kahal, for unmuting yourself. Number 6. Number 6, can I have Meryl for this, please? Let's quickly try to finish this until question 11.
D.
Okay, the answer will be D. Okay, 1/4 hertz. Guys, if you don't know how to calculate this, please learn how to calculate this. Okay, let's not waste time. Number 7, Vion. Oh no, the answer is given. Cannot. Sorry, I've given the answer. Okay, this is how you will count this. This is 6/4. Why 6? Because 1 wavelength, 2 wavelength, 3 wavelength, 4 wavelength. So 1, 2, 3, 4. Okay, there are 4 wavelengths in 6 cm. Okay, this is a circular wave, okay, which is almost the same as just now the question that Alvin made the mistake on, right? Okay, so we have to count the number of wavelengths and then we divide it with 6. That's why the wavelength is 6/4 or 1.5 lah. Okay, so 12 times 1.5 will give you 18 centimeters per second. Okay, number 8, Vion. Sorry.
D.
Okay. I hope you said D because I think I heard D lah. Okay, D for frequency and time. Sorry, frequency and period. Okay, frequency and period are inversely proportional to one another. Okay, F equals to 1/T. Okay. Wow, all the guys are so offended because they became 100 centimeters. Well, what to do? Dream is just a dream. Okay, we only can wish it will come true. Okay, number 9. Can I have Joey for this, please?
B.
Okay, very good. 10 meters. Amplitude. Remember, guys, amplitude is always counted from the equilibrium position, not this whole thing. That's not the amplitude. Apa lagi kalau ini adalah displacement distance. Okay. Which wave has the biggest energy? Okay, biggest energy. Can I have Ethan for this, please?
D.
Why D?
Higher frequency.
Higher frequency. Okay, good. I think it's a good try, although it's not actually correct. Let's take a look. Okay, so Ethan has got the concept correct. Okay, if you take a look at this, if you have a higher frequency, you have a higher wave speed. Okay, but we also need to take into account that there needs to be a big wavelength in order for it to have a big speed. Okay, so if you were to ask me to compare this and this has 1, 2, 3, 4 and 1/4 graphs. Okay, If this one is very, very weak, okay, this is obviously nothing. So it's either between C or D. If you were to ask me, I would choose C. Okay, simply with the fact that the amplitude is much higher. Okay, one thing that we have to associate, the wave energy, okay, is the amplitude itself. The wave speed, yes, it does contribute. Okay, I'm not saying that what Ethan is thinking is wrong. And actually, when I look at this question, I also thought D at first. Okay, because I thought, oh, okay, bigger frequency means bigger energy. Okay, but actually, what actually contributes to the energy of the wave, think about when you go to sea. Okay, when you go to the sea, on shallow water, the amplitude is very small. But in deep waters, okay, the amplitude is actually very big. The frequency may be the same, okay, but the amplitudes are big. And we feel more of the energy when the amplitudes are higher. Okay, another good comparison for us would be when you do music at small volume and big volume. Okay, so small volume amplitudes are small, so it's like less energy. Big volumes are when the amplitude is big. Okay, so like now if I'm talking very soft, it's like this. But when I'm talking, so it's big amplitude. So we usually associate amplitude with energy. And you know why frequency is usually not considered? Because, okay, low frequency, okay, so, sorry, this is low frequency. Okay, this is low frequency. This is high frequency. Okay, now, high frequency. Okay, so low frequency, the sound will be like this. Low frequency. Okay, and high frequency, although the same volume, will sound like high frequency. Okay, so this is, the volume is the same. And the volume is the same, low frequency and high frequency. Okay, so frequency just affects the tone of this one and not so much on the volume. Okay, the volume of the sound is affected more by the amplitude. So when you're looking at the biggest energy, we're looking at the one with preferably, okay, the bigger amplitude. Okay, preferably the bigger amplitude. All right, so we learn from this. All right, question number 10. Okay, last question. Sorry everyone, last question. Can I have, who haven't I called? I haven't called Nikki. I haven't seen Nikki for so long. Yes, Nikki, number 11, please.
C.
C. Hold on. Wavelength, what is this? What happens when the wavelength increases? Sorry, if the dipper produces 2 times wave per second, that is the frequency. When you increase the frequency, what happens to the wavelength? Oh, think about it. V equals to F lambda. Frequency and wavelength are inversely proportional to one another. Remember, frequency, wavelength is this one. So if you increase the frequency by 2 times, what do you expect the wavelength to be? It will decrease because it's inversely proportional. Okay, so it will increase by half. Increase by, divide by 2 lah. If the frequency, if the frequency is times 2, the wavelength will be divided by 2, which will be 1/2 lambda. Okay, so again, this is also a good question. Okay, so everyone take note of this. There is no homework. And so because there's no homework, I expect you to prepare for the tutorial either on Wednesday or on Friday. Okay, so that if I call you, then we don't waste time. Okay, we don't waste time waiting for people to find the answer. Okay, on Google. All right, everyone.